Hi everyone, this is a presentation video by Team 31, and I'm the only member in the team. I'm Zhen Zhihang. Today I will talk about the topic incorporating modern features. The goal of this final project is to enhance the accuracy and the robustness of image stitching. We have implemented image stitching in our assignment too. However, we know that image stitching still have some limitation. For example, the viewpoints change. Even a slight change in viewpoints can affect the stitching result. The change in viewpoints can lead to a poor matching of key points, resulting in incorrect or fewer good matches. The image below demonstrate a simple test. If I carefully move the camera horizontally and capture images using sift capture images and perform sift key point detectors, we can reach good result in image stitching. But if I make a rough movements to capture the image and perform sift key points, the stitching result becomes bad. As you can see, the image on the top side shows a well stitched and the camera movement is smooth and controlled. On the other hand, the image on the bottom shows a poorly stitched result due to rough camera movements. Therefore, I propose to improve image stitching from the perspective of feature matching. By improving the feature matching process, we can enhance the accuracy and the robustness of image stitching. So next I will conduct a survey focusing on the application of deep learning features to replace traditional algorithm features. I am to explore whether if there is a similar similar approach have been implemented in the past. Okay. This paper presented at CVPR 1920. It introduced LFNet, a method for learning local feature from images. LFNet utilizes a novel deep learning architecture that combines local feature extraction and descriptor generation. By training on large-scale image data set, LFNet is capable of learning local features with excellent discriminative power and variability. The figure shows we can observe that they also compare several traditional features extraction methods, including sift, surf, and the last and the last one is FNet, which demonstrates more metrics in terms of feature points compared to sift. We can see that there are more feature points to match. So I would like to explore the approach presented in this paper as a reference to utilize deep learning methods for extracting the key points. So how did I also do it? Let's see. There are two important networks called detector and descriptor. The detectors find the key point location on the input image. Then after we get the location of key points, we have to crop the image around crop the part around the key points to be a patch image, and the patch image is as the input as input of this distributor network, it will generate a distributor for each page you input. Then after understanding the general process, let's look at how the detector is implemented. There are three things. The first thing is to do the feature extraction. We have to get a feature map of this input image, right? So they also use GraceNetBlock to generate feature maps. And after we get a feature maps, we will use this feature map to perform this scale invariant key point detection. This will generate a scale space responsible map for extracting the key points. So we will get key points location by performing this scale invariant key point detection. And at the same time, we have to apply a single 5x5 convolution on the feature, which will output two values for each pixel. It records the sine and the cosine, and we can use this to compute the direction of the key points. So in summary, we will get key point location and distributor. We will get key point location and direction at this detector network. And after we get a location of the key points, we will crop the image, and after we crop the image around the key points, now we have to let this page go into the distributor. The architecture of distributor is simple. There are some convolution, batch normalization, rule excavation, and fully connective layer. It will extract image features, and FC layer will perform the linear transformation to obtain the final feature distributor. So input a page, and we will get the distributor. So in summary, we will, if we use this LFNet, I expect I can input an image, and this net will return the key point location and the distributor for me. So I can do the next things. And the next things, after we get the key point to descriptor, we have to match these key points, right? So feature matching. So I have do some survey about feature matching. I found this. This is a paper CVP. This is a paper present at CVPR 5020. MatchNet. MatchNet is a deep learning approach for image matching task. Its end-to-end learning methodology and variable scale matching strategy contribute to its excellent performance in image matching task, making it a promising approach with a wide range of application. So there are some important things. The first one is feature network. I think I don't have to explain too much. This just there are some convolution and pooling, and it is to extract the feature. After we extract the feature, the important thing is here. Here is the matrix network. The matrix network. The goal of the matrix network is to map feature representation to a matrix space, whereas similar images of features have smaller distance, and these similar images of our features will have larger distance. This type of matrix can be used in various applications, such as image retrieval, face recognition, object recognition, or more. The design of the matrix networks is simple. There are some fully connected and softmax. The network provides probability estimate for the matching and the non-matching of two patches. So the training process is like this. We'll input patch set, patch 1 and patch 2, and extract the feature, and then input to the matrix network to learn the similarity or the distance between pair features. Finally, we will output the matching. So let's say here are some of the expected approaches I will use in the future work. The first thing is the data set. I will use the hard data set as the experiment data. This data set consists of a collection of images. Is personal holiday photos. I think this data set is good at some tasks, like image staging is good for this data set. So in our previous assignment, we have already implemented these 4 points, which are the key steps in image staging. And now I plan to modify the key point detection method, or explore the possibility of applying the concept of matrix model to key point matching. I think the first thing is to implement the key point detector and the descriptor network first, and I expect that I can input an image and get a location of key points and its corresponding descriptor, and I will use these key points to perform the feature matching to enhance the accuracy of the image staging. So maybe the feature matching we used before is use KNN to compute the distance. Maybe I will try to combine this matchnet to get some similarity score, to learn similarity score. Yep. So the video ends here. Thank you.